Welcome to the video on 13-3 radian measure. We talked about it a little bit in our last section of notes when we talked about the unit circle and converting all of those angles. We're going to dive a little bit deeper today into how to work with radian measure and some applications. So the aim for today is to use radian measure for angles and to find the length of an arc of an angle using our radian measure. So just as a refresher, I'd like for you to find the equivalent measure for the following three angle measurements. We have negative 60 degrees. I want you to convert that to radians. And the other 2 radians, I want you to convert that to degrees. So just as a refresher, anytime we are converting from degrees to radians, we multiply by pi over 180. A way to remember that is when we have our degree measurement, we want to make sure that we have a pi in our numerator when we go to radians. So when I multiply, I want to make sure that pi is in my numerator. Now remember, the numbers in front just get simplified. We know 60 goes into 60 once, into 183 times. So this becomes negative pi over 3 radians. Okay, so negative 60 degrees, anything we do with negative 60 degrees can also be done with the measurement negative pi over 3. Now, anytime we go from in the opposite direction, from radians to degrees, we want to multiply by 180 over pi. Now, a way to remember that in most cases, we're given an example like 3 pi. Pi is already in our numerator. We want to make sure that we are able to cancel that pi out. So we make sure we multiply by something that has pi in the denominator to cancel out, which it does. So pi's cancel. We multiply 180 times 3, and we get 540 degrees. Okay. Now the tricky examples are going to be ones like this. 1.57 radians. Now this does not have a pi in it, but we do know that it is in radians. So we are still going to follow that conversion. We're going to multiply by 180 over pi. Now because, there's no fractions to be reduced, I would just plug this directly into your calculator, okay? Because there's no pi's that will cancel out here, so it's going to be an irrational number anyway. So when I plug that directly into my calculator, I get something like 89.95, ... Continue. This is approximately 90 degrees. Okay, so you could round that to approximately 90 degrees or whatever the question asks you to do. Okay, so being able to convert back and forth between these two notations is going to be incredibly important because everything we did with degrees in the last few lessons, we're now going to do with radians. Starting with, drawing these angles in standard position. Okay, how do we draw them on the coordinate plane? Well, we know when we are working with degrees that on the coordinate plane, 0 is in line with the positive x-axis, and each of those axes are 90 degrees away from one another. So we have 90, we have 180, we have 270. So one way of drawing these is to actually convert our radian into degrees and put it in the correct quadrant based off of the degree measure. So pi over 3 is equal to 60 degrees. So that's going to be an angle in this quadrant 1, 60 degrees. How about 5 pi over 6? Well, 5 pi over 6, we have to convert. This cancels, 6, we get 30, so we're in 150. So looking at our degrees, 0, 90, 180, 270, we know that 150 falls in quadrant 2. Now, different from quadrant 1, 60 degrees in quadrant 1 is its own reference angle, so we didn't have to label anything extra. But in quadrant 2, 150 is not its own reference angle. Remember, the reference angle is the angle that is made between the terminal side and the x-axis. So we're looking for the angle measurement of this spot. Well, when we were working with degrees, we would take this and we would take 180 minus the 150, and we would have 30 degrees left over. Now, that's great. The reference angle is still going to be 30 degrees with radians, but if the question was given to us in radians, we should label the reference angle with radians as well. So I actually should change this one up here. We had 60 degrees because I converted it, but that's equal to pi over 3. We have 150 on this angle, which I should really write as 5 pi over 6. And our reference angle here of 30 should be rewritten as 30 times 180 over pi. Oop, sorry. Use the reverse, pi over 180. So that's left with 6 pi over 6. Okay, so pi over 6 is our reference angle. We should know that is 30 degrees. Now, what about negative 16 pi over 9? It's the same thing, right? Negative angles are still going in the opposite direction, okay? So when we go to label this, we know that we're looking at the angles 0, negative 90 in this direction, negative 180 here, and negative 270 there, okay? So when I convert 16 pi over 9, and I multiply it by 180 over pi, that's 20, we get the angle measurement of negative 320 degrees. Now, 320 degrees, remember this would also be negative 360, is going to have a terminal side here, and it's going to end in quadrant 1. So, negative 16 pi over 9 is equal to that picture right there. Now, what is my reference angle? Well, my reference angle, again, is the same as when we convert it, as when we find it with degrees. So the reference angle for 320 is 40 degrees. So this reference angle in here is 40 degrees converted into radians. So that is going to be equivalent to 2 pi over 9. Okay, now that is a lot of work to be going back and forth between degrees and radians. You are more than entitled to do so, because I know we're very comfortable with degrees. But another way to look at these are in terms of their radian measure, getting comfortable with the way those are. So if you remember the conversions from our unit circle, if this is 0, 90, 180, 270, we could also label that with pi over 2, because that's equivalent to 90, pi, and 3 pi over 2. 2 pi for 360, all right? So now if we're looking at these, we can also plot by looking at the coefficients, right? If we look at the coefficients, maybe not so much in their fraction form, but if we look at this instead of pi over 2 as 0.5 pi, 1 pi, and 1.5 pi, if we look at the coefficients of the angles we're trying to measure, in this case 0.33 pi, we know that 0.33 is going to fall somewhere between 0 and 0.5 in quadrant 1. We know that if we look at this 5 pi over 6, 5 pi over 6 is 0.83 pi. Well, 0.83 is going to be somewhere between 0.5 and 1, so it should be in the second quadrant, which we still have. And if we're looking at the last one, which is negative 1.78 pi, well, going in a negative direction, we would go past this negative 1.5 and end up in the first quadrant. So you can also do it that way based off of the decimals that we should be familiar with the quadrant angles. Okay, the 0.5, the 1, the 1.5, the 0. Okay, so that is another way of plotting this if you don't want to go back and forth between degrees and angles, degrees and radians. So now, what kind of questions could be asked? Well, these are on page 848, numbers 23 and 25. It says, find the exact values of cosine and sine for each angle measurement. Okay, so we want to find the cosine of negative pi over 2, and we want to find the sine of negative pi over 2. Now, part of this is going to be understanding what's being asked. Now, we know how to find sine, cosine, and tangent of any angle in degrees. So one method of solving this is to actually convert our radian into degrees and to proceed forward. So negative pi over 2, that should be one that's sticking out to you. We know that's negative 90, but if you want to see the conversion, we multiply by 180 over pi and we get negative 90 degrees. So cosine of negative pi over 2 is equal to cosine of negative 90. Now, negative 90 is one of those that fall on a quadrant. Okay, it falls on an axis. It's not in a particular quadrant of this graph. So any 90-degree angle is going to fall on an axis. In this case, it's going to fall this way because we're going in a negative direction. Now, we need to think back to the unit circle for a minute. On the unit circle, right, let me draw that. A unit circle would go something like this. Our axis will intersect at the points 1, 0 over here, 0, 1 here, negative 1, 0, and 0, negative 1, right? Those are the ones that we know for sure because there's a radius of 1 on our unit circle. We also know on the unit circle that my xy pair is equal to my cosine sine value on the unit circle. So if we're looking at the angle negative 90, we're going to be looking at this ordered pair right here, 0, negative 1, right? So cosine of negative 90 is going to be equal to the x value of this ordered pair. In this case, 0. Okay, so what does that mean? Well, if cosine of negative 90 is equal to 0, that means cosine of negative pi over 2 is equal to 0, which is the answer. Okay, so let's try that with sine. Sine of negative pi over 2, we should know, is equal to the sine of negative 90. Negative 90 is a quadrant angle, so we're going to use the unit circle. And in this case, it's going to be equal to my y value where I intersect. So we're looking at this point right here because it's negative. So that y value is a negative 1. So my sine of negative 90 is equal to negative 1. Therefore, my sine of the original question is equal to negative 1. Okay? So that's how we would figure this out using the unit circle. Now, notice this question asks for exact values. There's only very few angles that we can find the exact values for. And those are the quadrant angles, right? Because we know how to use our unit circle. As well as any angle who has a reference angle that is 30, 60, or 45. Okay? Because we have those special right triangles that give us the exact values. So we're looking for quadrant angles. And anything with a reference angle of 30, 60, or 45. Everything else cannot be found exact values. You would have to use your calculator, which I will show you how to do.